when you are designing a device, a wireless device, and maybe you are not an expert on that field, you most probably would go to a distributor, known distributor or major distributor, go there and say, I need Bluetooth antenna or whatever, narrowband IoT antenna, and you will get thousands of results, like a kid on a candy store. Okay, what should I pick? We simplify that choosing process by providing a simplified portfolio, and also, of course, by providing tools as Oxion that guides you to the selection process.
20 billion devices, IoT devices in the world today. 20 billion. This gets better. This gets better. 2025, 40 billion devices. So any design engineers out there, if you can do this well, you've got plenty going on. That means 80 zettabytes of data wandering around the world, talking to each other, moving stuff around. I don't even know what a zettabyte is, but it sounds like a lot to me. That then equates to a $500 billion market. Big business. And Ignion, igniting data, making things better with Aitor, is going to tell us about, in fact, it's not just about IoT, it's about wireless, which is a bigger contextually market. And he's going to introduce us to how you collect, send, and act on data. So let's talk about that first. Let's put that into the context. Let's talk about antennas and tell us about some of the themes that are going on, things like security, compatibility, and standards. You don't have to stick to those. You know more about this stuff than I do, but I thought that might be an interesting place to start. So Aitor, over to you.
Well, thank you so much. Well, you said that, no, interesting business, and a lot of things, a lot of homework to do and to complete to get there. We were just while preparing that podcast, we were talking about it, and one of the things that actually surprised us in Ignion about the IoT space and the wireless space in general, because at the end we don't stick to IoT. There's plenty of wireless devices out there that need an antenna, so we are there for them as well. But the IoT space, particularly talking about it, is a space that we have been talking about it quite a few years already, and we are expecting it to grow, and where the analysts, as you say, are saying, those numbers where we are going to be in 1, 2, 3 years, 5 years, 10 years. So, as I said, there is a lot of homework to do. And at Ignion, at the end, we try to put in place tools and technology to make that thing happen. No more than that. And to provide developers the simplicity to get there and to not spend time and headaches on the RF side of the things. Yeah.
So first question, lots of talk. We visit a lot of shows. So we visit shows and we get buzz talking about what's going on in IoT. Mm-hmm. There's, for I think, is something that doesn't make any sense, but a lot of, the idea that the big picture of IoT has failed because we don't have coffee machines that talk to the internet. We were never going to have coffee, even when the concept of that sort of idea came along. That was always a nonsense. It was never going to come to anything. But because they're not, IoT's failed. So when you talk about wireless and when you talk about IoT, and you're talking about where you can see that being successful, just explain to us where you see those applications where it is changing the world, it is making the world a better place. So you talk about wireless. Let's just go into where you see that being successful, and then the applications where you see IoT actually bringing real value to the world.
Yeah, no, absolutely. We are seeing different industries within or verticals within the IoT industry that are actually driving value and making a difference on implementing wireless and Internet of Things technology, and to let's say improve the end customer's life, which is at the end is the goal of every developer out there, to provide a product, a device that it's let's say making the end customer lives easier and more robust in terms of data communications and IoT in general. But we are at Ignion, we focus on, or let's say we see value on three main verticals, what we call let's say the three verticals that are actually adding value to the space, to the end customers. And those are smart metering. We see a lot of huge deployments out there on the smart metering space, on the electric water metering. At the end, you have super wide areas where you need to deploy meters, and we let's say we changed people's life on the smart metering space I'm talking about right now. For example, no, you don't need to just, or there is no technician coming to your home just to read what the meter is saying to then charge you and selling you a bill. Now this is completely over the air. We send this data thanks to the antennas, of course, and the wireless part of the device. So this is optimizing a lot of different processes on the smart metering industry and the energy industry in general, but also for the final customers. And then we also have the asset tracking, what we say asset tracking and logistics. No, at the end, anything that needs to be tracked and anything that needs to be, let's say, communicating its location at certain point. And this is also impacting really hard on the supply chain management, right? So and then as final customers, and you may be feeling, you may be facing that as well, Guy. You, when you buy something online, let's say you want to know where it is and where it will get to your place, right? So all this data, of course, it's not just coming from the GPS or GNSS in general location information, but it's also, or the GNSS and the wireless side of it, it's contributing a lot on that space for the final customer, but also on the supply chain, let's say, managers that are in the industries out there, where they can plan better, they can also get more information from their daily business. And then maybe the last one that I can talk about, or a couple of them actually, if I can, it's automotive telematics. We've been driving connected cars for a while right now. It's not something new, but there is also an aftermarket industry which is huge and needs to increase as well. No, and also in terms of security for the final customer, the final user. For example, now at Ignion, I cannot disclose that much because it's not been, let's say, public yet. But there is a lot of specific assets that contribute to security, that by providing, or let's say enabling connectivity on them, you can provide a safer one. No? And one of them is what we call flashlights. It's a small device that you put on top of your car if you have an accident or you have a mechanic problem that you need to stop by in a road. So you don't need to just jump out of the car, go and put this triangle, old-fashioned triangle, walk 50 meters, put it there. Maybe it's completely dark outside, so it's dangerous. Actually, it's a dangerous situation. So by providing connectivity to those devices, now it's just a small device like this that you can put just on top of your car, and it's transmitting in real time your position, and then the authorities can act accordingly. And also the mechanical, let's say, your mechanic can come and solve the issue you have, so you don't need to close to a danger. So that's a real use case. That's something that is adding value to the industry, but also to the final customer as well. And maybe last but not least, we cannot forget about maybe the biggest, let's say, industry out there in terms of communication, which is the Bluetooth industry, right? So everything is wireless now. Maybe the microphone is Bluetooth or Wi-Fi, wherever. Then we have the mouse, a PC, whatever. No, so at the end, and then on the gaming industry specifically, where the data latency and the quality of the communication is critical. No, because you don't want to be playing a game and then the mouse is not responding, and then you cannot do what you want. No, so we need to provide reliable and robust solutions on that aspect as well. And it's actually one of the spaces we see with a lot of value from Ignion standpoint, where we can provide solutions for optimal performance, for example.
Okay, good. So for context sake, what we're talking about, and the reason why you differentiate between IoT, is because you've just given some examples there of machine to machine interface where data is going from one thing to the other. So we know in both of those cases, the context of this podcast, the context of this introduction about Ignion is getting the data from the system, off that system, going to wherever it needs to go. So whether that be IoT with its $25 billion, $50 billion market, or heaven knows what the size of the wireless market is. But anyway, but we're all about data. So today, design engineers, they have to understand the implications. First of all, even if they're working in the system, they have to understand what are the implications for the point of moving the data off the system to its destination. So talk me through today, when you started the company, when you're interacting with customers today, what would you say is the very typical use case you find with how design engineers today move that data from that system to its place of destination?
So as I was saying, no, so Ignion was founded on top of the research and development of a new technology that is called virtual antenna technology. And the main difference of that technology is that it's what we call a non-resonant element. It's like, okay, what does it mean? No, it's an antenna and so on. It should resonate. Of course it does, but we do not stick to a specific frequency range to design our antenna portfolio, which
Right.
means that the same antenna component could operate at the frequency we want. Of course, we cannot beat physics. There are some limitations. No? So at the end, we have larger products that are more oriented for low frequency ranges, and then we have smaller products that are oriented for, let's say, higher frequency ranges. So at the end, this technology is actually what makes us different, not only from a technology standpoint, but also from the benefits it provides. No? So when you look at our portfolio is just 6 products, no more than that. And we can offer a solution from 400 megahertz up to 10 gig. So it's, at least we believe that it's quite impressive. So as we were saying, no, we need to make things simple for the developers. And this is actually one of the things we have already done. We have simplified a lot our portfolio so we can keep just 6 antenna products on it. So when you're evaluating an antenna solution for your device, it's much more easier. No, at the end, for example, one of the examples we normally, or the comparisons we normally talk about from Ignion is a candy store, no, a kit in a candy store. So
Right.
when you are designing a device, a wireless device, and maybe you are not an expert on that field, you most probably would go to a distributor, known distributor or major distributor, go there and say, I need or a Bluetooth antenna or whatever, narrowband IoT antenna, and you will get thousands of results. So the feeling that it's a little bit, as I said, no, like a kid on a candy store. Okay, what should I pick? So
Yeah.
we simplify that choosing process by providing a simplified portfolio, and also, of course, by providing tools as Oxion that guides you to the selection process.
But at the end of the day, you're going to have a spec for your application. The chances are your spec isn't necessarily going to be the spec that other parts of your product range or other parts of your business may need.
Mm-hmm.
But so you're going to say, right, I need an antenna that's going to get the data off my system to get it to go wherever I want it to go. And you have then answered, I think. I will let you speak, by the way. Because you're the one with all the answers. I've just got the silly questions. So what you're saying is, if you went to a big broadline distributor, of which there are many, many choices, you put your spec in, and you're going to get thousands of answers. You're going to get so many answers. You go, oh, okay, right. I've got to choose 3. I've got to choose 5. I've got to evaluate them. I'll tell you what. I'll just go with the one I've got. and probably that's not the right one. So your proposition is, hang on. You don't need to go through that chaos. You could just have 6, and they're all flexible because we cover the bandwidths, all the bandwidths in that family. Mm-hmm. So whatever you're trying to achieve, we've got them. So there's not thousands, there's 6 because we cover all the frequencies. And what you're going to introduce to us in a minute is we've got a platform that's going to make that integration really, really easy.
Mm-hmm. I cannot summarize it better than that. Yeah.
Is that, in summary, that's what you are saying?
Yeah, absolutely. And of course, I mean, let's also be honest, no? And there are a lot of developers out there that know a lot about RF and know a lot about antennas, and this feeling of the kid on a candy store doesn't exist for them because they know what they are doing. But we also need to take care about all the other developers out there that maybe they are not experts on the RF field, so they need more guidance.
Let's just remember where we started this conversation. Yeah. Let's just go back for fun. Let's go back. 40 billion devices. This is not including wireless because we didn't start there. We started on IoT. 80 zettabytes of data. So let's just say 15 zettabytes of data. They know what they're doing. There's a lot of zettabytes of data with people who are kids in a candy store going, oh, where do I even start? Okay, good. So and then so we talked about the context, and then we talked about actually don't there's so much to worry about in a system, particularly now with everything that's going on with AI, speed, data rates, power, everything that's going on. Everything has its own context on the board. Everything has its own context in the system. You're saying, let's just at least make our bit of it as user-friendly and as easy for you to do in the way that we do it.
Exactly. So at the end, of course, as you say, we cannot forget that in any device, but particularly in a wireless device, on IoT device that we are talking about today, so the RF side of the things, it's not the only one there. It's one of them. And there are a lot of aspects that you need to take care when designing a device that are always critical. No, you mentioned few of them, but there are a lot. So as you say, what we are trying to push here is this provided autonomy first. So you don't need to rely on third parties. You don't need to rely on paid services to go through that antenna selection process. And then the second one is you may need guidance on picking or selecting the best choice for your specific application or a specific use case.
Yeah.
And at some point, when you are designing a device, you need to fully understand or to fully acknowledge your use case. So if you do not have total control on your use case, so at the end where your device is going to be deployed on the field, what is the final application, all these aspects need to be considered when designing a device in all the different aspects of that device. So we provide this kind of tools and we provide this kind of technology, as you say, to simplify that process. So we can also provide you guidance on, okay, this is your use case, this is your best antenna choice or your best, let's say, antenna design for your specific case.
Right. Okay. Good. So we're going to put to one side the developer who absolutely knows everything about their antenna, because they've decided already. They know what they're doing.
Yeah.
They may still be wrong, of course, but we'll leave them to that. So we're talking about a developer which will be the majority. People have got a kid in a candy store scenario. So I think there's two questions. You talk about you can help integrate. I think it's really important with a company that is relatively young. I mean, what's the definition of relatively young in the world that we live in?
Well,
let's be honest. But, it's not like you have 50 years of heritage in the antenna world.
No.
Okay. So, yeah. And at the end of the day, which I think people just don't talk about enough, is these are massive decisions. These are huge. Every component, every software, every decision is actually huge. And it has ramifications, and we take that far too lightly in the industry that we work in. So to get the right antenna, you're saying we can help you choose the right antenna. But at the end of the day, I can go to a big broadline distributor and they can offer me thousands. So they've got a solution. So just give me some background. That's the first question. Just give me some background about why you believe, and let's call it heritage, because obviously some very, very clever people at Ignion. You don't come up with this solution because you don't know what you're doing. You come up with it because you do have heritage. It's just not particularly in the name of the company called Ignion. There's the very clever people at your company. Just give me some background about the team, because I say, big decision. You go to your boss and you've got these 100,000 devices you're going to put out in the field, and he says, I've chosen the antenna. I've gone with Ignion. And the director of applications goes, what? Hang on. I've been in this business for 700 years. I've never heard of Ignion. Why are we choosing them? What would you say at that point? What's the point that says you've talked about a breakthrough technology? That's always a game changer. Always, because this industry is all about game-changing technology, doing something new that puts you ahead, time to market, whatever it is. Just give us some background. Doesn't have to be long, because I think the technology speaks for itself, but just some background about why you can absolutely trust, if you go down the route of evaluating your 6 antennas, and why that's a very trustworthy decision to make, because it's a high calorific decision. Making a decision like that is not to be taken lightly. So, just briefly, tell us.
Sure. Yeah, I mean, the quick answer on that one would be we have a proven track record. So we have already provided our solution to more than 50 million devices out there. So
why do you think that is? What was the reason that they chose you as opposed to those thousands of other bits of candy on the shelf?
Well, I would say the first thing that customers say about us is our excellent customer support. So at the end, we provide. I know our customers are really happy on the process, what we do from the customer support team, engineering team, but also of course our sales guys, following up with them and trying to solve, because we normally try to go the extra mile and not just meet targets. So at the end, we want to provide them with the most optimal solution and the most reliable solution. And of course, we have a technology that can make it. At the end, the virtual antenna technology, one of the benefits it has is that as a non-resonant technology, we have much more flexibility on tuning the performance of that antenna. Sorry, on tuning the response of that antenna for the specific use case. So we can, in the final device, actually do some changes. We have some flexibility to get where
Keyword. That was the word I was going to use, just as you said, flexibility. So let's just backtrack. We talked about bandwidths. We talked about, every antenna has its absolute strength, but you offer the whole of the bandwidth. What you're then saying is, if you then choose a particular bandwidth, you then have flexibility within that bandwidth to tune even better on that specific application.
Yeah, because at the end, it's not realistic to assume that the antenna performance that has been, let's say, theoretically considered for its design will not change in the final device. There are a lot of different aspects in a final device that can impact an antenna response, an antenna impedance, an antenna performance. We can talk about batteries, we can talk about displays, we can talk about any metallic component that is in the device. So if you stick to a static, and specific frequency, and a specific antenna designed for a specific frequency range, you can end up then having problems in your final device because you don't have that flexibility to get to the changes that are actually being impacted by the different elements on the device. And this is why our technology provides that level of flexibility, but not reducing the performance, which is of course critical. Let's be honest. We can talk here about flexibility, we can talk about simplicity, but at the end, what you want as a developer is that the device works, no more than that.
Yeah.
And works as it should and gets the performance that you need for the real application. So our technology is shining in complex environments, as I was saying. So in the smart metering space, for example, where you need, in some cases, for example, let's talk about a global deployment. You can have a full range of, let's say, frequency bands that you need to cover. So that's complex from an antenna standpoint, because you have the bandwidth is quite big. So you need to tune your antenna to be performing at the same level. That's of course the goal within the entire bandwidth and the frequency range, and that's not always easy. And our technology enables to do so because of its core, its purpose and its own let's say design process. And then maybe another point here is that it's not something that it's normally considered up front during the antenna selection process, but we cannot also forget about the procurement guys or the product manager guys. So when you are deploying, let's give you an example. When you are deploying globally again, you may have different products or different device versions depending on the region you are going to deploy that device. Let's say the frequency bands in Spain might be different from the ones in the US or different from the one in China. But we do not have specific products per region. You can use the same part number for your bill of materials independently of the region you're going to deploy that. So from bill of materials standpoint, it's much more easy to manage. As you say, IoT devices always iterate. There are new versions and new processes because, of course, technology keeps improving. You need to be out there and following the path of the industry. So by reducing the number of part numbers you need to manage in your bill of materials, it's also something that we see as an added value for our customers.
Right. Okay. So I think in summary there, what you've basically said is, I mean, we cover the technology bit. We talk about the bandwidth and the high bandwidth, the low bandwidth, depending upon your product. But then what you've, I think just to summarize that, what you've then said is, in actual fact, there's going to be, even once you've chosen your bandwidth, so you could have chosen a tenner, once you put it into the system, there's going to be iterative changes because there always is. Okay. And then the reality is that even then, even when you then go deploy out into the field, because we're dealing with things like bandwidth and we're dealing with different regions, you're still going to be faced with the need for flexibility. And the beauty of that is you're just going to be using the one supplier for those iterative changes and those geographical or application stresses, if you like, because as I think you just said, you bring out one product, 6 months later, you're having to bring out another product. Exactly the same product. It's just a bit better than the one you had before. But you don't have to go through the whole process of doing everything all over again.
Yeah.
Okay. So
this is just an example. No, we have let's say the communication standard space is continuously changing. So now, for example, in the cellular space, we are already talking about the 6G, and then in the future, in the upcoming years, 7G will come. So you need to also keep the path of that change in the communication standard space.
Yeah. Okay. Good. So I think that really covers off. We've covered off overall context of the design engineer facing their problem. You've then covered off technologically how you solve that. So we've got I know who you are. I understand who you are. You give me some reasons to trust you. Big decisions, remember, so they need to trust you. So at that point, they need to evaluate you. So last part of this conversation. I've gone through that process as a design engineer. I've decided that I'm not going to go through the candy store scenario for all the reasons you've just given, which is iterative changes, geographical changes, things you're going to need to change. So I've bought into the whole Ignion story. Now I've got to evaluate you. Quickly summarize. If I'm a design engineer listening to that, I absolutely trust iTalk. I now need to actually go down that. I need to go down that journey of actually evaluating you. Talk us through the experience that design engineers are going to have at that point.
So at Ignion, we like to say, or we like to promote the design journey in 4 or 5 main steps. The first one is what we present as proof of concept stage or feasibility stage. Now you have a product idea, you have something in mind, a brilliant idea in mind, and then you need to put that in place. No, you need to put that start working on it. So what we try to solve here, or how we address that stage, is by providing tools such as Oxion platform, where our users can go input their idea in terms of course, what impacts the antenna side of it, and then we can provide with recommendations, and we can provide with the best kind of options for their idea to work, of course. And the second step would be what we call the design stage. Now, the design stage is at the same time composed by different steps, and we start what we call with a PCB design file review, where we check that all the design recommendations have been followed, that there are no issues, that all the components are where they need to be. And then once this subtask is kind of completed, we move to the next one, which is the prototype stage. In the prototype stage, what we ensure is that, of course, and to put a little bit of context here, we come from kind of a digital domain, a digital prototype that you have validated in the proof of concept and feasibility stage. But you need to validate that on the real world, right? So I think we all agree that digital versus real world there is always a difference. So in that stage, what we have is a service where our engineering team gets this physical prototype and starts fine-tuning the aspects of the design and the bill of materials to ensure that we get the optimal performance out of it. And this is key. And then we have the 4th step, the last one. It's not always required, but we like to present that in the design journey. And it's what we call the pre-certification stage. So in some cases in the IoT space or for any wireless device, you need to certificate, for example, if your device is going to operate in the cellular space, right? So you have mobile operators that have certain certification targets that you need to meet if you want to operate in their network. So we help our customers in that stage with active measurements in our laboratory here in Sant Cugat in Barcelona, and we make sure that what you get out of it, you are ready to go to the certification process. The certification process is an expensive process. I'm sure that customers out there can confirm that. So we need to address that uncertainty, let's say, by providing this type of service and make sure that there are no complications once you go to the certification, the real certification step. So that would be kind of the design journey we push our users to follow.
Okay, so let's talk about Oxion. Let's finish off with talking about Oxion. Let's talk about the platform. Let's talk about the autonomy that it offers, and how, I mean, at the end of the day, giving design engineers time to market, giving them the ability to evaluate things quickly, and you give them that level of independence to go and do that, to support them. So just talk us through Oxion quickly.
So, Oxion is, as I said, a platform that we have been working on for the last month and last years. We have been working on that concept because as a company, we push to make things simple. So what is Oxion? And which is actually a really good question. So Oxion is what we call an AI-powered antenna integration platform, which means that it helps you integrate an antenna in your device. As simple as that. Of course, as I said, the design journey is defined by 4 main steps. So the roadmap that we have, and we can talk a little bit at the end of the session, is willing to encompass the entire design journey in an automatic way, providing that autonomy, as I was saying. But today we are focusing on the proof of concept stage, solving this kid on a candy store scenario. No? So Oxion provides different benefits, but the idea or the main purpose of that platform is to provide an environment where developers can just sign up. It's completely free of charge. You can then, of course, log in, start your project, input your requirements, and see in a really user-friendly interface the results of that proof of concept stage. As I said,
so what are the so when we're talking about proof of concept, obviously they're going to be putting in certain data sets. They're going to be putting in so what are those data sets? What do they need in order? I take it's a form that is going to have certain parameters. We could just look at that form if you like, but essentially, what's the things that they have to have in order to fill out and say, right, this is going to give me proof of concept? How does that work?
So and we can share that so the audience can also see how easy it is. But it's a really simple 3 steps form. The first one is you just need to create a project with us, and so we ask some project information and of course some business information that we can also use it to plan accordingly the stock and the different business operations behind. The second one is your design. Just name how you want the design to be named. Give us some PCB dimensions and PCB shapes. We can either manage rectangular or circular PCB shapes. Provide those dimensions, and last but not least, the wireless services you would like to integrate. As easy as that. Then you just click create, and it's completely automated. No, and we can provide this proof of concept stage actually in real time in most of the cases.
Right. So, and when you say that, based on those 3 things, out of those 6 products that you have, they're going to basically, one of them is going to pop out at the bottom of that system.
What we push and what we do through Oxion is we enable our recommendation engine. So out of our portfolio, you get what's the best fit for your specific use case. Knowing your use case is critical to get optimal performance and to make sure that you then not fail issues once you are deploying the device.
Right. Okay, good. So I think the most important thing about this whole discussion is that we went into the world, we started this discussion understanding the huge variety. I mean, let's just go again, 20, 40, 80, those are the figures. 20 billion devices today, 40 billion in the next 5 years. 80 zettabytes of data. They're just fun bits of data. But they gave context to the complexity and the vastness of what design engineers are being faced with today. In summary, then, you explain at the end of the day, you've got to get this data off the product, whether it be in an IoT device or in a wireless device. Mm-hmm. You explained that there are thousands and thousands of choices of antennas. You've said the reality is what we can do is we have 6 and they're all flexible. So the reality is if you come to us, we will give you that. 6 will cover all of that off. And then the most important thing then is if you choose 6, we then have nuance within those 6 so that when you're doing the fine tuning in the system or if anything changes, we can deal with that.
Yep.
So somebody then has gone from knowing the context of their world. They now know you because we've made it very clear, I hope, on this discussion, what you do. You get the data with an antenna off the system. I think you give them really good background and understanding as to why they should trust you. Because at the end of the day, we've talked about these are big decisions. If you've already chosen your antenna, if you always use one in your application, you always have done, they probably should still come and talk to you. But at the end of the day, they're going to use their own. They're going to use their already defined choice. Mm-hmm. So if you're starting a project in the areas that you've discussed, you talked about all sorts of nuance, all sorts of things that could potentially change. So you need real flexibility. And that's not just at the design, but it's in the bit of material too. Mm-hmm. At that point, is there anything else? And I'm just saying this is a rhetorical question. At that point, is there anything else that you'd need to know to say, I'm going to go and fill out that form for evaluation? Because I think there's no reason why you wouldn't at this point, because it's then the design engineer can engage with you because they've got a real project. They need to make 100,000 of something that's got to communicate somewhere in the world, do something. So I think that you've given a very, very good foundation of where are you? Where have you got to be? Come and talk to us. We can solve your problem. Mm-hmm. So I think it's an excellent introduction as to why in a very, very, very complicated part of the system, and one that's got to integrate with everything else that's in that system, and that's the nuance bit. That's the bit where things need tuning and changing. Why a design engineer, why they're working in IoT or in wireless, should come and have a chat with Aitor mm-hmm. and his team at Ignion. And I did get the name of Oxion wrong because I called it Oxion because I'm stupid and I'm English. Oxion, and go through a journey of finding the right antenna for you. So, Aitor, thank you very much for your time today. And I think that any potential design engineer should come and have a chat with you about how you can help them solve their antenna problems.
Thank you so much, guys. It's been a pleasure. I mean, we are always open to have these kind of discussions and to help anybody out there solving the issues they might find, and of course, picking the right antenna. Thank you so much.
Thanks for watching. If you want to learn more, go to ipXchange.tech. As always, like, comment, and subscribe. Keep designing.
Hey, where my engineers at?